All right. A stiff, a stiff straight copper wire XY is held fixed in an uniform magnetic field of flux density 2.6 10 to the power minus 3. B is equals to 2.6 10 to the power minus 3 Tesla. Alright, so we have a stiff wire, uniform magnetic field of flux density 2.6 10 to the power minus 3. The magnetic field goes straight and the wire is at an angle 34 degree. The wire XY has a length of 4.7 centimeter and makes an angle 34 degree with the magnetic field. Calculate the force on the wire due to the constant current 5.4 in the wire. Alright, we know for the force, magnetic force on a wire is given by force is equals to magnetic flux density, current, length, and sine theta. The theta is the angle between the wire, direction of current, between the direction of current and the magnetic field, which is over here 34 degree. We can also we will just substitute the values 2.6 10 to the power minus 3 for a current of 5.4 amps for a length of 4.7 centimeter, which is 4.7 10 to the power minus 2, and sine 34. It will give a value of force 3.69 10 to the power minus 4 Newton. The current in the wire is now changed to an alternating current of root mean velocity, root mean squared value 1.7 amps. Determine the total variation in the force on the wire due to the alternating current. If this is the root mean squared value, then if this is an alternating current, the root mean squared value is supposedly like this, so it will have a peak values, and due to the peak values the force will alter because force is proportional to the current. Over here we'll take the peak values because it will vary between these values. So we can write, let's find the original current root mean squares equals to original current over root 2. So the original current will be 1.7 root 2. It's 2.4 amps. It's 2.4 amps. So the force, what will be the force? What will be the new force? So we can say the maximum force will be, because for the maximum amplitude, for the maximum current, we'll have a maximum force, which is BIL sine theta. B is 2.6 10 to the power minus 3 for a current of 1.7 root 2, length 4.7 10 to the power minus 2, and sine 34. You will give a value of 1.64 10 to the power minus 4 Newton. Alright, now what will be the variation of force? You have to understand, the maximum force, you can see this is our maximum current, this is our maximum current in the negative direction, the positive direction. So when the current is maximum in this direction, we have a maximum positive force. When the current is in this direction, we have a maximum negative force. So what does the variation mean? The variation is the total difference between the forces, which will be double the single force.